here's a big W. The question is how to make half of a W. Shouldn't that be a V? Well, here I'm trying to make half a W by cutting it in half this way, which is a very difficult way to make half of the area. A line divides this shape, which is made of 5 unit squares, into 2 equal areas. The 2 equal areas are this part on top and this part on the bottom. What is the distance between the rightmost corner of the W and the rightmost endpoint of the dividing line? We're asking for this distance. At first, when you look at this, you ask, couldn't they have asked an easier question of cutting it this way? Why are we doing this version? The reason we're doing this version is it shows a very interesting technique for calculating areas. One way to do this would be to maybe set up a coordinate system and count all of these areas. What I mean by set up a coordinate system is that you could, for example, turn the whole thing on its side and say that this is the y-axis and this is the x-axis, and you put some coordinates down so that this point here is at 0, 3, and this point here is at 3, 0, and then you want to know what the coordinates of this point are, a, 0. Then you can go and find out every one of these intersections, calculate all the areas, and it will take you forever. So let's not do that. There must be a better way. An idea on how to do these is that when you're calculating areas of complicated pictures, one way is, of course, to add areas together, like what I just discussed. The other way is to subtract areas. Can we see a way that these funny parts, this red and this blue, are subtractions of areas? Actually, I can. It's easier to do it with the blue one. If I finish this, I would get a complete triangle. And that's the key. The key is actually this picture is drawn here, so you don't have space to finish it. So it suggests that maybe you can't finish it, but you can. You see, what you should do is perhaps try finishing this like this. And of course, underneath, the same thing is happening. So what is actually happening here is that I have a part of a 3 by 3 square. Let me draw the 3 by 3 square. Now I'll draw the 3 by 3 square this way. I'm using yellow because now I'm going to draw the actual W on this square in black. So this is my W. And I'm cutting my W into 2 parts using a line which is doing this. Now, I was interested in the areas, and I want them each to be half. So right now I have 5, and so I want each area to be 2.5. Since I said it's easier to finish off on the bottom, what I'm then looking for is I'm then wondering how to make this triangle have an area which is 3.5. If I want that area to be 3.5, now what I need to do is I need to know how do I multiply base times height to go and get 7, because I have got half times base times height. For that, let's remember how long each side of this big square is. If that's 3, then if I want 1/2 times base times height to be 3.5, then I have an equation which is 1/2 times 3 times this unknown part. We actually had called that A in the way that I was doing it with the other picture. This is supposed to be 3.5, which is 7 over 2. And if that's the case, then I find out that A is equal to 7 divided by 3. Well, now I'm almost done. Because if A is 7 divided by 3, 7 divided by 3 is 2 and 1/3. And here, I want all of 3. So this last piece right here is just 2/3. 7/3 plus 2/3 is 9/3, which is 3. That's actually all there is to this question. The key to the whole thing was to say that a complicated shape can be made simple by finishing the shape. And the idea is that sometimes, even though addition is the thing that's more obvious to look at, subtraction of areas can give you the much simpler solution.